Hi everyone, welcome back again to PLAXIS 3D Shallow Foundation course from theory to practice. This will be lesson 14. We are going to investigate the effect of groundwater table on the factor of safety of 3D slope using PLAXIS 3D. If you remember in a previous example, we simulated this problem using PLAXIS 3D, but we didn't consider the availability of a groundwater table in the problem. So in this example, we will bring the PLAXIS file from lesson 39, and we will save it under a different name, and we will only add the groundwater table like this figure. As we can see, the water table is located 2 meters below the ground surface at horizontal ground ground surfaces. Also in this region it will be interpolated automatically. So we open the PLAXIS file from lesson 39. So I will save this title, and this is the PLAXIS lesson from previous example, lesson 39. So I will save this file under a different name. I will click on File and Save Project As. So we will save it in lesson 40. So this one will be the name of this lesson, or title of this lesson. I click on Save. Okay, so we proceed to soil tab. As I said, in here the water table is located 2 meters below the ground level. So I will click on each borehole. For example, I will double click on this borehole, and in here the water table will be at 8 meters. It can be calculated right now again. So we click on calculate to start the calculation. We calculate all phases from the beginning, and we will wait until the calculation is finished. After that, we can see the factor of safety and how the factor of safety will be changed with existence of water table, also the surface failure of the slope. So we will see all of these in results of PLAXIS. So we will wait right now until the calculation is finished. So as we can see in here, the factor of safety increase until a specific value, and after that it becomes a constant. Actually, if we want, we can stop the calculation in here, because the factor of safety is stabilized in here. It is about maybe 1.3. So if you remember, in a previous example it was about 1.730. We can see that with the existence of water table in slope, the factor of safety is considerably decreased. But I will wait until all the calculation is finished, because sometimes some students and course participants say that I don't want to share something in calculation. That's why I stop when the PLAXIS runs the calculation. That's why from now on I will record all the lesson, include the calculation as well. Okay, as we can see, the calculation was finished, but in here we have some error. it says accuracy condition not reached in last step. So when we get some errors like this one, we can solve it by decreasing this value, because in here tolerated error is 0.01. maybe we can change it to 0.05 or less, but also it will take a long time, as you saw in this example. So I think it is enough. So but when we get something like that in factor of safety analysis, actually it is not a big problem. You can also change the mesh and repeat the calculation again. So in here also we can check the factor of safety. We click on factor of safety phase and click on edit phase. So in here we can see the reached safety factor is about 1.312. So in a previous example it was about 1.7. so we can see it has been decreased considerably by existence of water table in slope. Also we can click on view calculation results. Okay, so we can see in here we can see this is a deformed shape of the problem. Actually in factor of safety phase we have a very large deformation or displacement. Actually this deformation in safety analysis doesn't make any sense or physical meaning. To see the failure mechanism of the slope, we can go to deformation, incremental displacement, and click on here. We can see this is a failure surface of our slope, as we can see in here. Also we can click on deformation, incremental strength. This is also a failure slip surface of the foundation. Again we also can check the factor of safety against the displacement. We can click on curve manager and click on new. So in X direction we will have the point at the slope crest. Also in Y direction we will have the safety factor. Okay, so as we can see in here the factor of safety is about 1.3 and 1.312, and this is for this tutorial. As I said, this warning or error not very important in safety analysis. As I said, we can solve it by decreasing this value, or maybe we can change the mesh as well. We will try in this example and we will see the result. So in this example this was 0.25. maybe we use 0.5. also we click on generate mesh and we will use maybe a coarse mesh. Click OK. So we click on stage construction mode, and again we start calculation. Also I will stop the video to decrease the tutorial length maybe, or maybe I will wait, maybe it can be run more quickly because we used a coarser mesh. Okay, we can see the calculation is finished, and in this time we don't have any error in here. Also we have okay, we don't have any error or warning, and the factor of safety is almost the same. It is 1.365 in previous example. In first time it was 1.312. So we can see there is no big difference between the results. As I said, also if you don't want to use a cursor mesh, you can decrease this value and repeat the calculation again and see the result. Okay, this was for this tutorial, and I hope it was clear. Thank you for watching. See you in the next lesson.